Alright guys, got a little job to do as part of the saddle modification, or the cross slide modification to mount the slotter on. I need to drill and tap a couple of holes in that to allow that slotter to be mounted so we can run it. I've stripped the entire saddle assembly down to do that modification on the milling machine, but I've had a look at my cross slide screw and the nut. I've had a little bit of a concern for some time with the amount of backlash that I'm getting in there at the moment. So looking at it, the screw is in pristine condition. There is no wear, as I've measured that all the way through. No discernible wear in that at all, so I'm happy with the way that is. The nut on the other hand, and we probably can't see in there, but the nut is badly worn, very badly worn. I'll take you in and show you a lot of the bronze that's mixed up with the oil. You can see the amount of wear that's visibly see the wear that's come out of this. So that needs to be remanufactured to suit that screw. Now I've had a look at this. It's a bit of an odd one. It looks like it's actually been shaped with a shaper. Looking at the tool marks on it, it's a pretty crappy old bit of stuff. It's obviously been set up in a forge at some time, and I don't think this is original. I think this has been made since the machine was new. The root diameter on the screw is 12.6, and the root diameter on this comes up at over 13 mil. So there's a fair bit of slop on the root diameter on this, and there's a fair bit of slop all over on this. It's I've got to remember it's a left-hand thread. So there's a fair bit of slop in this. It's got this very crude arrangement there for taking up any of the backlash with this slot and socket-headed cap screw just to squeeze the threads together. The screw doesn't appear to be standard, although I reckon the nominal size would be 5/8. Which is about 15.9. It's measuring up at 15.39, 15.4. 10 TPI, which is an odd size for a 5/8. They're normally 5/8. It's an Acme thread, and it's a left-hander. So we're going to have a go at making up a new nut and tapping that. I should say single point threading that in the lathe. I'm actually going to do that threading in a mate's lathe. Obviously it's a bit hard to do that with my lathe stripped down, so we're going to go to Peppy's place and use his lathe to cut that thread. The stock that I'm going to make this out of is this old slipper plate. Now this is a job I worked on many years ago at a very large multinational fabrication company that I worked at that did call aluminium fabrication. This is one of the rewinder slippers that I did an awful lot of work on, doing a lot of redesign and upgrading of this machine to be able to handle heavier coils. And this is one of the old slipper plates off the Spider assembly. So I phoned up one of my old contractors that used to do a lot of work for me, asking if I could get a stick of bronze about 2 inches in diameter, and he said, well, we've got some of your old slippers here if you want to use one of those. So that's the perfect bit of stock, so I've marked that out, and we'll use that as stock to mill down to size. And we'll bore the hole in the mill, and we'll get that over to Peppy's place, and I'll single point that screw thread inside. So very tight. That's the boring bar that I'm going to use, and I've got very little room between the outer diameter of this and where I start the cut. So it's going to be a very tight sucked in screw, and I've only got about 0.2 of a mil. But I can have that sticking out a little bit further than what it needs to be, so not a lot of clearance with that one. So it'll be a little interesting job. We'll get this done, get that knocked up, reassemble again, we'll get the modification to the saddle, and then we'll try a bit of slotting. Alright guys, we'll catch you out on the floor. Okay, so just to show you very quickly, that's the oil and grease, and you can see that, focus that, but there's an awful lot of bronze particles that's in that. That's the thrust washer at the very end, and once again with the grease and oil, that's got a lot of bronze particles through it as well, which has discoloured that oil or grease. So there's been quite a lot of wear in that nut, hence the reason we're making a newie. Okay guys, one of the things I need to do on this is to get fairly accurately the dimension from the top of the nut, where it bolts up underneath the cross slide, and the centre line of the screw. Now there was an awful lot of slop in this, so all I've done is I've just put some Teflon tape on the thread, and I've run it past. I've just put some Teflon tape on this side. I'm just going to run it back. And what that's going to do for us is that it's going to take up all that slop that we've got in there. Now I can accurately set up and measure from the top of this to the top of the thread. I know that's 14 or 15.4 mil in diameter. I can take the half of that and I can get fairly accurately to the center line of that, and we'll set that up in the mill, and we'll bore this through ready for threading. So it's just a simple way of taking up slop if you want to measure things on threads. Alright guys, we're going to go ahead and do this bore now. I'm going to do this in the mill, get that in preparation, ready to cut that thread over in Pepe's lathe. I've measured that screw up, cross slide screw up, very, very accurately, or I think I've measured it up very, very accurately. The root diameter on the screw actually comes at 12.6, so we're going to go 12.7, 12.75. I want to keep that fairly tight. I want to keep this nut fairly tight if I can, and we can do any final adjustments in the lathe when we're actually cutting that thread. So yeah, so we'll get that drilled and bored out to 12.7, 12.75 for that root diameter. Righto. Right, we'll just take an initial cut on that, and we'll see where we're sitting as far as the ID goes. Let's see, we're aiming for 12.7, and we're at 12.44. 12.44. Right, we should be pretty close with this now. Found 12.75. Right, we'll leave it at that. Right guys, so we're just going to grind this tool steel, this 3/16 tool steel, down to an Acme threading tool. So included angle is 29 degrees, so half that we go 14.5, and I just use the surface grinder just to grind these in, and then I'll just hand grind in the clearances that are required on that leading edge for this internal tool. So there's a bit of 5mm stock. I'm going to have to give it a lick down just to get it to fit into my boring bar as well. But we'll cut the tapers first, and I'll bring you back when that's done. Alright guys, I've got 1/2 mil to go on that front land, so I'll be bringing that down incrementally and measuring with the micrometer. Now the way I do these, it takes a bit of feel, but open them up and you can push up and down on the micrometer. Make sure you're at 90 degrees to the front face. Push it up and down. And keep moving it until you can't catch it on both sides. And that's about it there. Catch it top, catch it at bottom, it's only just going in. So I've got 1.45, I need to come down to 0.95, so I've got exactly 1/2 mil to go. Alright, we'll see how we go. Alright, we'll see how we go with this. The camera's not real flash for picking this up, but we've got our 29.5 degree included angle ground on both sides. This is going to be my leading edge, so I need to relieve that back by about 4 to 5 degrees so that doesn't rub whilst we're cutting the thread. And I've just got to relieve that back. That's the groove that's been left as we've plunged down with our wheel on our surface grinder. So we'll get all that tidied up. I've got just shy of 1 millimetre across there on the flat, so I'm happy with that. That'll be it gives a little bit of clearance. As I said, I want this to be as snug as I can get it. Alright, I'll head back and I'll freehand grind in those clearances, and we'll just relieve that edge there back a little bit and get that square, because this is going to sit very, very tight inside that boring bar. Alright guys, we're not on the battler workshop today, we're in my good mate Pepe's workshop, and he's letting me use his lathe to cut this Acme thread for my nut. So we've started that, we've cut about 0.3 deep, so we've got a bit more to go yet. So we'll set the tripod up and we'll do a couple of runs. Right, because Pepe's lathe is a metric lathe and we're cutting an imperial thread, I've got to leave the half nuts engaged the whole time and just reverse the tool out each time while we're still engaged. Righto, so what I might do is bring you blokes back when we're getting very close to the finish. Hi guys, well I'm back in the battler workshop. The nut thread came up absolutely magnificently. We've got one problem. I thought it was a 10 TPI thread, but it's actually a 2.5mm pitch. So it goes in beautifully for about 10mm and then jams up. And I've made this mistake before in the past, and I've made it again. So the primary measuring units on my cross slide are actually imperial, not metric. So my assumption was, when I put the thread gauge on it, it measured up on the thread gauge length, spot on 10 TPI. But over 100mm, it's bang on 2.5, and over 4 inches, it's just off the pitch. So I've got to cut another nut, bore it out, and head back over to Pep's, and then recut the thread. So we'll get all that done, get back to the stage, and then we'll show you the final fitting up on Pep's lathe. All right, guys, I'll hang my head in shame, and yeah, we'll get on. All right, guys, we finally got there. That is a very neat fit. I've got no axial float on that at all. Right, so what I'll do now is I'll take this home to the battler workshop and we'll do our drilling and tapping in the top for our mounting screw. We'll do our slit and we'll do our drilling and tapping for our wear adjustment. Hi guys, well we're back here in the battler workshop, back from Peppy's place. So we completed the Acme thread inside here, and it's worked out perfectly. Yeah, apart from that little blue we did originally with the 10 TPI when it was actually 2.5. Obviously on that tool too, the thread angle for an Acme thread is 29 degrees, and for the trapezoid metric threads it's 30 degrees, and that relates to around about 0.4 of a thou difference in the root thickness, so less than half a thou. It's about 0.01 of a millimetre, so I'm certainly not going to worry about that. So it's an Acme thread form inside the trapezoid, but that's fine. I've got to do the final machining on this, and we've got to set up the backlash elimination on this. Now with the original one, it's got this slot here, and it's got the single M6 socket-headed cap screw that just upsets the thread just to take out the backlash. That's only engaging by about 2.5 threads. Sorry, yeah, about 2 threads actually. So I'm actually going to move the slot back, so I'm engaging 5 threads, and I'm going to put 2 M5 socket-headed cap screws just down the sides. So I've just done a quick little sketch on that. So just 2 M5s just down the side with the slot a lot further back, so we're engaging a lot more teeth, a lot more of that thread in that upset. All right. Just one thing, when I was over at Pep's, cutting Acme threads or square threads can be a bit of a pain trying to work out if it's rubbing somewhere, if it's rubbing on the flanks, whether it's rubbing on the OD, whether it's rubbing on the root of the thread. It's sometimes very hard to pick, and even when you put a Sharpie marker on, it's very, very hard to pick it as well. And Peppy showed me an absolute fantastic way of how to witness a thread going in here, and it just makes it so easy, and it stands out like no man's business as to where it is actually rubbing. There is no mistake. There is no, oh, is that a bit shiny? Is that the black gone? Very, very hard to pick sometimes with a Sharpie, but this method that he showed me was absolutely brilliant. Now, Peppy's a first-class machinist out of Spain, extremely experienced operator. What he doesn't know about machine shop operations isn't worth knowing. He ran his own tool making business for many, many years, and very, very experienced man. I've certainly learned a lot of tips off Peppy. All right, we'll get this set up, and we'll get our centers worked out where we're going to do our drilling and tapping. With the slot, I've been contemplating whether I'm going to use a slitting saw, but I think I might just use a hacksaw and just split that down. I can do that fairly neatly with that, and it's a lot quicker too, so I might just do that, and it works out at exactly 1 millimetre wide. It's to touch over, and I don't have any slitting saws that are 1 millimetre wide. I've got them around about 0.7 of a mil, or I've got them at 2 mil, so I might just use the hacksaw to give me the slit that I want. All right, well, I'll go ahead and get this set up, and we'll come back when we're starting to do some drilling. Righto, so that's drilling and tapping completed on our nut. I've got the mounting screw in there now, and that's thread there. There's a very, very, wouldn't say firm, but it's a nice feel. So I'll go ahead and mark out, and we'll just use a hacksaw just to come down there, and then we're ready to start putting the cross slide back together. Now we can get this slotter mounted and see how it all works. Alright guys, we'll see you soon. Alright guys, we'll cut the slot on this. I've marked it out where it's got to go, so we'll see how we go. It's going to take it very easy. So that's it done. Beautiful and straight. I'll deburr that. I think we're ready to start putting our cross slide back together. Righto guys, we've got our nut and screw assembly in place before I put the actual cross slide saddle back in place, but that's just how I want it. I've got no backlash in that whatsoever. I've only just done those up, just nipped them, and that's just caught it out beautifully. I've run this up and down a number of times just with a drill, just to get it bedded. And yeah, I'm very happy with that. Alright, I'll get the table back on. We'll get the thrust bearing assembly back together. We'll get the gibs reset and tensioned, and we're back in business. Oh yes, got to put the DRO back in too. Alright guys, we'll catch you shortly. Righto guys, we've just about got the cross slide back together. I'm just setting the final gib inside the slideways here, and sometimes it's very hard to know what sort of tension to put on the gib to get that just right, particularly when it's still hooked up to the nut and you've got to crank the saddle backwards and forwards. I disconnect the nut and just give it a feel. That's quite firm now, or I should say. It's firm, but it's still able to move quite comfortably. So I'm fairly happy with that. So I just adjust the gibs until I'm happy with the feel that I've got. Sometimes the nut's a little bit tight, it sort of masks how that gib is set up. So if you disconnect it from the nut and just run it by hand, it does the job for you. Alright guys, we'll continue to get this back together. Get my DRO back in again. And then we can start look at setting up for our slotter. So we've got our new holes drilled and tapped in there, ready to accept that. Right, we're getting close to getting this assembled. Alright, we'll see you soon guys. Righto guys, we've now got the cross slide fully assembled, the DRO is back and working. We have the tiniest amount of backlash in that, and that's feels wonderful. Virtually no backlash now. As I was going about quarter of a turn, and you get this, and you could shake that pretty violently, and you could feel the backlash in it, but this is all back together, all tightened up again. We're done.